From a total of 11 languages and dialects used in Egypt, two are non-spoken. The Arabic and Egyptian Sign Languages are currently the only known means of communication for a population of more than 7.5 million people living in Egypt.
For this reason, we have chosen to construct a two-way communication system to accommodate the deaf and the hard of hearing. Our main objective is reducing the number of difficulties the deaf and the dumb communities face on a daily basis by both giving them a voice and a method of understanding a speaking person.
Our project can be divided into two parts: a smart glove system responsible for translating the sign language gestures into their corresponding Arabic letters and words to be then displayed in both text and audio forms on a simply designed mobile application or web page.
مرحبا.
And a 3D printed human-like arm system with 2 degrees of freedom and a voice recognition algorithm that converts spoken Arabic into their respective sign.
We used an MCB3008 ADC chip to enable us to read the analog values of 5 flex sensors placed in their designated pockets on the glove, worn by the disabled person, along with an accelerometer and two touch sensors that are placed in specific locations on the glove to distinguish between similar gestures. The data configuration is sent to the Raspberry Pi for processing and fed to the neural network, which is designed to predict the Arabic letters or word. The predicted output is then sent to the web page, where a simple press of a button will display the text or the audio.
For the ARM system, a similar button will be supplied to the mobile application or web page to enable voice input. This input will then be passed to a speech recognition algorithm that will translate it to text to appear on the screen, as well as generate the suitable servomotor angles to display the corresponding sign language gesture on the arm. For the PWM required by the servo motors, we used a PCA 9685 chip to provide more PWM pins.
And they used the neural network model as a convolutional neural network that can classify the input sensor configuration to its corresponding Arabic equivalent.
Another convolutional neural network will also be produced to classify the Arabic text generated from the voice recognition step into the set of servo angles required to display the sign language.
For our current progress with the glove subsystem, we have designed a glove from a flexible material that can still hold its shape. We were able to implement separate compartments or pockets for the flex sensors and accelerometer.
From there, we have generated the dataset for all 28 Arabic letters from the combination of values from these sensors. The touch sensor values will be added in manually until we add specific padding of a different material at the points in contact with the touch sensors. We will also be adding words to the dataset in a second phase of this step. With the ARM subsystem, we have 3D printed a human-like arm design with fingers that can close all the way to permit 3 positions of bending for each finger. Through strong thread and servo motors, all 5 fingers and wrist can be moved. We are currently working on constructing the suitable dataset of servo angles with their corresponding Arabic letters and words. For our second phase of the arm, we will be using it to spell out complete words.
Our chosen convolutional neural network construction was tested to an open source dataset and was found to be efficient. Our next step here will be to pre-process our data to fed the CNN, train it, and test it in Google Colab for the required behavior.
ألف باء تاء
In our current phase of the project, we are using a Raspberry Pi 4 for each subsystem for its processing speed and Wi-Fi and Bluetooth features. During our work, we use an Ethernet cable for a stable process.
Since it is not very convenient to carry this arm around everywhere, our project can be applied both separately and together.
The smart glove can be applied in day-to-day activities at home, at work, and with friends. It will be a helpful assistant in speech therapy, in nursing homes, and special needs schools.
The ARM subsystem can also be used for educational purposes in schools, special needs schools and orphanages, events, nursing homes, speech therapy clinics, and for general group use anywhere.
In the case of separate use of the glove, a feature of displaying the sign language in animated form on the application can be added.
In the end, it's important to emphasize that hard of hearing and speech impaired people are not a minority. And with the current progress in technology, it's our role to do our best to provide them with their basic human needs of being understood. We hope our project can help these people feel more integrated into society for a world of more inclusivity. And finally, where there is room for improvement, there is room for more of the human experience. Thank you for your consideration.